You may have heard of the recently announced breakthrough research in nuclear fusion at the Lawrence Livermore National Laboratory. This can potentially provide abundant clean energy. Here's the 2-minute explanation of nuclear fusion from a physics perspective. Nucleus A is composed of protons and neutrons that are held together by the nuclear force. In order to separate this stable nucleus into two smaller nuclei, B and C, energy is required. The minimum amount of energy needed is what would bind B and C together, their binding energy. Since this is intuitively clear, let's see what happens if the process is reversed. In this case, nuclei B and C are fused together to form nucleus A. Since the process is reversed, energy must be released rather than provided. It is given off in the form of heat and light, the amount being the binding energy of B and C. It's feasible to convert heat to electricity, making this process potentially useful. Water can be heated to produce steam, and steam can be used to turn a turbine, producing electricity. What the production of this useful energy really comes down to is Einstein's famous equation, E equals mc squared, which tells us the mass of an object is equivalent to its energy content. Applied to the fusion reaction, this means that some of the mass contained in B and C has been released as energy while forming nucleus A. This means the energy contained in B and C equals the energy contained in A plus the energy given off by heat and light. The fusion reaction has released a more useful form of energy. This is the same basic process by which the sun produces heat and light, although there are multiple and more complex reactions that occur in the sun. So there you have it, a 2-minute description of fusion and its potential to produce electricity.